All right. So you have any in the equation? What the questions from 3.6 are going to be word problems that will require you to take a derivative with respect to either x, y, or r. Just depends. And then you'll have a chain rule, but it's going to be implicit chain rule. So it'll be slightly different. So let's say I want to take the derivative. Let's take the derivative of both sides with respect to x. So this is what you're going to do. d dx of both sides like this. d dx. So I can't use the prime anymore or the quote because you need to know which derivative with respect to what variable I'm doing. If I want to do y or r, I have to write it. So d dx of x squared plus d dx of y squared. You don't really need the parentheses. Oh, forgot the two. So when you would do the quote or the prime, you would be doing it with respect to, well, we only had one variable in those questions. So if we had a bunch of x's, the prime meant dx. Okay. But now we're choosing dx and we don't have nothing but x's. If they match, right, you do it the same way you've always done it. So this would be just 2x. Derivative of this will be different because see how they don't match, the x and y? It'll start off similarly. You're going to get 4y. So bring down the 2. You guys see, I skipped a step there. You guys cool with that? Or do you see where the 4 came from?
Yeah, did you just do the prime or whatever?
Yeah, the power rule, right? Just bring the 2 down. So, is that cool with everybody? Okay. So bring down the 2. And then you do times the derivative of y with respect to x. So this is the implicit part. So derivative of 2y will be 2y squared is 4y times dy dx. So you add this like chain rule piece. This will be the same. What's the derivative of r squared?
2r.
So same deal, but tack on dr dx. You see what I mean? So that's the rule. If you're choosing dx and only some of them match, then you'll have to tack on this implicit piece. Is there any questions about how the main idea? Okay. Let me know.
So is it always going to be a 2r dr dx?
Pretty much. Just treat it like a little chain rule. So all the derivative rules you've learned, do it the same way. Just tack this on if they don't match. Ink.
Okay.
So let's do the first one in the homework. Check it out. So they want us, so here we're gonna do the derivative with respect to x. But at the next step is they want us to solve for dy dx. You see that? So we're gonna do some algebra to figure this out. But the hint is they want dx on the bottom, so I need to take derivatives with respect to x. That's what that means. So number one. Find dy dx by implicit differentiation. So given this guy, do the derivative with respect to x on both sides. So dx times 3x squared. Just do each term. You can skip one step if you want. And the derivative with respect to any variable of a constant, what is this going to be?
Zero.
Yes. Yeah, exactly right. It doesn't matter if it's x, y, z, r. Derivative of a constant will always be zero. These match. What is this derivative?
6x.
All right, so we get 6x. Since they match, you don't have to tack on the dx part. I mean, you could, but dx over dx is 1, so who cares? Derivative of this guy. Did I write this? Yeah, it's the same thing. Okay. It'll be 6y times dy dx. Okay, you guys still with me up to this point? Okay. So they want dy dx. So do the algebra. Isolate this piece. So let's move the 6x over there. Divide by negative 6y on both sides. So dy dx is equal to x over y. Any questions on the algebra? Right here. Okay. I'm going to move on then. Let's do a harder one. So number two, check it out. This would be the same, but during the derivative, you're going to have a product rule here and here. And this would just be 0, so who cares? Here you'll have a power rule with big powers, just fine. And then you just deal with the y and this x over here. Let's see. The next one, yeah. Would you guys like to do 2 or 3? Which one looks harder for you? Okay, let's do 2. Yeah, I think 2 is longer. Okay. Find dy dx by implicit differentiation. Five x squared y plus 4y squared x equal to -7. Oops, I'm all blurry. Okay. So they want us to, since they want us to solve for dy dx, that's your hint that you should do d dx. I don't know why I wrote that at an angle. Okay. The derivative of this piece is a chain rule. So the derivative of the first part. So this is how I'm going to do it. D dx of the first piece times the second piece plus derivative of the second piece times the first part. All right. Derivative of this will be d dx of 4y squared plus, oops, times derivative of the first times the second plus derivative of x times 4y squared. So she kind of jammed that in there. Sorry. So derivative of this is going to be 10x y, right? That y is just there. What's the derivative of y? This piece here, d dxy. Derivative of this piece, right? Derivative of y is going to be 1. But then you do the implicit piece. And then times 5x squared. That makes sense? So that's this piece. Derivative of this is derivative of 4y squared with respect to x. Yeah, it's gonna be 8xy, but then we tack on dx dy. Okay. Derivative of x is just going to be a 1, right? No more implicit piece here. That's it. Oh, forgot. Damn it. I didn't write it up here, but there was a right-hand side. Derivative of this would be 0, so I'm going to put it down here. You see what I'm saying? This is all right. It looks like crap. They want us to solve for dy dx. So back to basics, solving for a specific thing. Apparently I'm dyslexic. You need to put all the pieces that you want on one side. So keep these two together, move everything to the right-hand side. So I have dy dx 5x squared plus 8xy dy dx equal to negative 10xy. So subtract this piece and subtract this piece. Up to this point, are you still with me? Okay, let me know. So we did the implicit derivative. We had to do two product rules, and then we moved everything that wasn't dy dx to the right-hand side. So now factor. We'll have 5x squared plus 8xy. Divide both sides by this, and we're done. Oops. So there we go. So dy dx is equal to negative 10xy minus 4y squared over 5x squared plus 8xy. Any questions on the algebra? Yeah, I mean, they're all going to be like this. It's just some will be uglier or easier, right? The whole goal is to keep solving for dy dx and doing your implicit derivatives. So the derivative will be either really difficult or simple. It just depends, right? Yeah, as you've seen, chain rules, quotient rules, product rules, it all depends. Some of those really suck. Some are simple. It's just you have to tack on this extra piece. And once you've done it, do your algebra to isolate. So let's go ahead and do let's see.
Is that the final answer, Professor?
Yeah, they want a dy dx. So this is the derivative with respect to x. But you see how it's implicit? Technically we can reduce it, right? I forgot about that. Can let me see. No, can't.
Professor, just a quick question.
Uh-huh.
Where do you see our class average? Because I don't see it in my Canvas.
I'll check
I'm
after class. Maybe it's not turned on. But I'll check. But again, I haven't graded your exam, so the only grade that should be showing is your homework. But I'll make sure it's posted.
Okay, thank you.
Okay, so you guys are cool with number 2?
Yes. Can we see another example?
Yeah, let's go ahead and do 3 then, I guess.
Actually, Professor, if we could do one
Huh?
of the same, like number 2, just a different problem.
Sure. I mean, I'll make one up for you if you like. To alter. Okay. Okay. So again, 2 product rules. They change the powers and numbers a bit, but it'll be very similar. So dx of the first piece, 3xy cubed plus dx of 2y squared x to the 4th equals to dx of 4. So do your product rule. Derivative of the first piece times the second piece plus the derivative of the second times the first plus again, so this is the chain rule for the first term. Now chain rule for the second term would be dx of 2y squared times x to the 4th plus dx of x to the 4th times 2y squared equals to 0. Okay. So far, do you guys see how we are applying the product rule here twice? So for this derivative is these two. This derivative is these two. This derivative is 0. Okay. So these match. Derivative of 3x will simply be 3 times y cubed. Derivative of y cubed, what is that going to be?
Sorry, derivative of what?
Y cubed.
What?
Right? It's just a power roll, right? Bring 3 down. And then times the chain rule piece for implicit. Yeah, so it'll be 3y squared times dy dx. Now again, derivative of 2y squared.
So 4y dy dx.
Yeah, 4y dy dx. Then that x to the fourth is just hanging out. Derivative of x to the fourth with respect to x. What is this going to be? Oops.
Is it 4x and d or dx?
Four x cubed 2y squared, right? We don't have no chain rule piece. Is there any question? So that's the derivative. Is there any questions on how to get to this step and doing the product rules?
What was that last part that you said? Oh, it doesn't have the dy dx, or why doesn't it have the dy dx?
Because they match up. This is ddx of an x type. So just treat it like you usually do.
Oh, okay. Okay.
So like this one, derivative of 3x is 3.
Okay. I got it.
Yeah, derivative of x to the fourth is a power rule. Bring down the 4, subtract 1. You want me to write it down? Or do you see
No.
Olivia?
Yeah, no, I got it. I got it. Thank you.
Okay. We both got it. Cool. All right. So they want this though. So isolate this and then factor it.
Oh, I wanted to apologize. I'm sorry. I didn't know if you
Mhm.
if you were talking to Olivia Munoz also. Sorry about that. I
No,
didn't see
you're good, man. You're good.
I didn't see the chat. Sorry, Olivia. Apologize.
Excuse me. Okay, so subtract this. To the right. Okay. All right. So I subtracted this term and that term here. Factor out dy dx, that'll be 3y squared, 3x. Although I should probably combine that, huh? Three y squared times 3x is 9xy squared. Factor out dy dx, that'll give us plus 4x4y. I put the x's first for no reason.
Okay, I was wondering about that.
Yeah, because we all know multiplication commutes, so you can rearrange them however you want. No reason for it. Then I'll just divide it out and we're done. I just noticed that's 4 times 2, huh? So dy dx is equal to this garbage. Does that reduce?
No, it doesn't look like okay.
Is there any terms that are in common up top and bottom if you were to factor?
What 8x and 4x?
Well, you have to factor from on both terms on top and both terms on bottom.
Squared or y?
Yeah, the y, right?
Yeah.
That's the only thing we can do. You could also factor a negative out for no reason.
Yeah.
That'll be 3y squared plus.
I think it's okay.
Okay. Sorry, go ahead.
And the second one, do we factor the denominator too?
Yeah, because the only way you reduce something is if you factor the top and bottom and then cancel a common term. And the only common that I see on top and bottom is y.
We also have x.
But not on top, right?
Okay.
So if you can factor, the only time you're able to cancel is if you have a product.
Okay.
So that's all I can do. But I factor a negative, so you could put the negative in front just because.
Do you put the recording today or tomorrow, Professor?
The what?
For this class, the recording.
I try to do it as soon as I can. Just depends if things get crazy.
Okay.
Um, I'll try to do it
Oh,
early morning, if not tonight. Just depends how late we stay up.
okay.
Okay. Now you see that you can no longer reduce, correct?
Yes.
I know it's tempting, like, oh, I see that 3 and 9, but don't do it.
But can we do that?
No, you cannot. Don't do it.
Yes.
It has to be factored out. The only time things cancel. All right. Any questions on the derivative part or the algebra part? I think half the problem was calculus and then the second half was algebra. Yeah, it is. We've only done like 3 problem. It's already 9 o'clock. Okay. You guys are cool on number 2, alternate. Let's move on to 4. I don't know why I put it. Okay. So they want dy dx again. So you're going to do d dx of both sides. What kind of derivative is that square root going to be?
Is it xy into the half power?
Yeah, that's true. That is a good first step. Change it. Okay. Do you see that you have to do a power rule, but what do you do with the inside?
Do we need to do something with the inside?
Yeah. It's the chain rule. You can't just do the power for no reason. You gotta do both. So you would do the power rule, right?
Yeah.
So it would be x.
-1.
Yeah.
Oh yeah, so minus. Well, actually, so it'll be minus 2/2.
And that would become
Okay.
-1, though.
Yeah, let's show this step.
Yeah, that's true.
That'll be 1/2 minus 2/2, which is the 1, which gives you the -1/2. Right?
Yes.
Yes.
Now deal with the xy. So you're going to have times the derivative of the inside. So you have a chain rule that's implicit. It came from that square root nonsense. So now they're pretty much combining all of chapter 3 into like this one little piece right here.
So that, are you saying it's going to be -1/2 x?
This entire thing will be negative. We'll have a -1/2 on it. Power.
Okay.
Right, because it's going to be, you guys subtract 1, right? That's the power rule. So 1/2 minus 1 is a -1/2. So that's the outer function times the derivative of the inner function. So this is a chain rule problem. You guys okay with this first step?
Yes.
Yeah.
Okay. So that's this side. Derivative of this is a product rule. So d dx times x to the third y plus d dx times the y times x to the third plus 0. Okay, you guys cool with the product rule setup here? Okay. Just let me know, because I know it's just this section is assuming that you're a pro at the last few sections, but you're still kind of practicing it, right? So I understand if it feels difficult. And if it doesn't, that's great.
The derivative of 14 is 0, right?
Yes. So this is the 0. Derivative of this product rule will be, so that whole thing will be times d sorry, it's not skip steps. Product rule says d dx of the first piece plus d dx of the second piece times x, right? Equals to derivative of this is going to be this guy, right?
Yes.
Plus 1 dy dx x cubed.
Where did we get the dy on the top from? Like the y?
Here.
The top one. Yes.
The derivative of y is going to be dy dx. So you derivative of y is 1 times the chain rule part,
Okay.
the implicit rule.
Okay.
So so that one is coming from that as well. So that d dx. Let me see. So I got a little confused.
And derivative
Where did
of
we get
y,
that very last one? That plus 1 dy dx. Where did you get the one, or where did the one come from?
well, think of it this way. What's derivative of x?
Say that again.
It's
What's the
1.
derivative of x?
It's 1. Yeah.
Yeah, so treat it the same way. The derivative of y is 1, but then you have that implicit piece gives you dy dx.
Okay, I gotcha.
And then this x cubed is just hanging out.
All right, got it.
Okay, so now let's keep on going. So this will become derivative of x is 1, right?
Professor, I can't see it.
Oh, sorry.
Thank you.
Derivative of y, what is that going to be?
1.
Times dy dx, right?
Yeah.
Equals 2.
Can we not say 1 instead of the x?
I'm sorry?
Like you said it's like the y equals to 1 and then you said dy or dx times x. The last x, can that be 1 or not?
This x?
Yes.
If I were to do a derivative of this, it would be 1, yeah,
Okay.
with respect to x. But I'm doing a chain rule because it was technically a derivative of x and y. It's x times y.
Okay,
So this turned into this product rule.
okay, got it.
Okay. Again, we could kind of get away using the primes a little bit, but we want to get away from it because eventually you're going to have a word problem and you're going to have all the variables. You're going to take the derivative of all your variables with respect to time because you're going to be doing a word problem. So you have dx dt, dy dt, whatever, right? Radius dr dt or something.
They're going to be word problems.
In the next section, not this one.
Oh,
So this one is just trying to get you used to this idea of implicit derivatives. And then the next one, we're gonna actually use it for something. Do you agree that this first term right here, or this first factor, is the same as 2 times square root xy?
Yes.
So, and this is just gonna be y plus dy dx times x. Okay, so I'm gonna have to distribute this, but since it's at the bottom, you could write it this way if you wanted to.
I couldn't see it. Thank you.
Right. You agree that this is the same 2 times square root xy, you just put it on the bottom of these two since it's times this.
But what did we do with the one on top?
Which one?
Like you said, 2 square root of xy, where is the one on top? When you distribute
This one?
I think
yeah.
he just multiplied it into that, right?
Yeah, 1 times this is itself. This times the bottom is right here.
Okay, got it.
I was thinking the same thing though.
Yeah, just think of it as like 1/2 times x, right? You would just have x over 2, right?
Yes, that makes it clear.
So this garbage times that thing, whatever. Okay. This algebra is getting a little nasty because we still have to solve for dy dx, right? The derivative is done. It was done a while ago. But now notice we got the dy dx stuck up top and we have it over here. So that kind of sucks. So how would you simplify this to make it easier to isolate this guy?
Can we do like terms?
Do what?
Like terms? We don't have like terms actually.
No, yeah, we don't. This fraction is annoying, correct?
So could we do a common denominator or not?
We could. Um,
Or multiply it by 2 square root of xy to get rid of the denominator, maybe.
yeah, that's what you want to do is get rid of the fraction because dealing with it is annoying. Because
Yeah,
I gotta isolate this top part and group it with this.
yeah,
That's on the other side of the equation, and this is stuck inside of a fraction.
yeah.
So right now life sucks. So get rid of this fraction. think I might need to use another page.
Are a lot of these problems going to be about this long? Uh,
Yeah, I mean, it just depends on how hard the derivative is. And then,
And do we need to get explanation for that on the test as well?
no, I mean, these are just solving, just isolate dy dx. That's all we're asking. That's it.
Alright, I just had a misconception when I did the test. I was writing everything for each questions, how I did it, so it took a lot of time.
Yeah, I'll make sure to take that into account. Did you guys need more time?
Yeah, for sure.
Okay, I'll put more time next time. To distribute this nonsense. Okay, so now I can subtract this over here, the y over there, and solve for dy dx. You guys still with me up to this point?
Yes.
yes.
It's I know it's a lot of algebra on some of these. Okay. Let me know if I'm losing you. All right. I have to rewrite it because I ran out of space. So subtract this guy over here, subtract the y over there.
I think it's equal, you put a minus
What's up?
after the dy dx x, you should put, I think, the equal sign, and you put minus.
No, I'm rearranging the terms.
Oh,
I'm moving this.
you move this to the right. Okay, got it.
Yes. You guys, does everyone see what algebra we did? I skipped a minor step. Yeah, pretty much. All right. What else we got here? Yeah, that's all we can do now is factor this out, and we're almost done. Divide this out, and we are finished. Finally, dy dx is equal to that right-hand side. And this is what they pretty much want. Now, I'll be sure to give you partial credit if you're able to do the implicit derivative but not solve. I'll give you something. Any questions on any of the steps here?
No questions on this one. Professor, when is the next exam?
I don't know. Let me see. Not for a while.
And which chapters will be in the exam?
All of chapter 3.
Only chapter 3?
Right.
Okay.
So I would
So
guess
it starts from 3.1, right?
3.1 through 3.8.
Okay.
Uh, Probably towards the end of October.
So isn't there a specific date for that?
I would want it done before Halloween. So let's go for the 30th would be the latest. Preferably 23rd if you can.
23rd. And the last date would be the 30th of October?
Last day is October 30th. The early I would prefer it's done the week of the 23rd.
So
That's for the second test, right? You're saying?
Right.
23rd. So the test would be open on the October 23rd?
I might open it sooner. I don't know yet. Maybe next week I'll open it up.
Okay, thank you so much for the information.
Then feel free to take it or do it early if you want to. But
I will if I have time. In sooner.
let's see. Okay. We were at the very beginning because these take forever. We did number 4. I can't do them all for you, so let's try to choose
Can
some.
we do a graph one, please?
Graph.
Yeah.
Uh,
I like that number 12.
you want to do 12?
Yeah.
Or I don't know. I don't know if that's what she's asking, but it's
But if it's just have a graph,
Yeah, this one.
yeah.
Okay, sure.
Thank you.
So they want us to find the equation of the tangent line. So that means you need dy dx. Solve for, and then you plug in this point. That would give you the slope. Then use the formula, point slope formula, find the equation of the line. So this is stuff that we did at the beginning of chapter 3. It's just that we're doing it on a more difficult derivative.
Okay. All right.
Okay. Find the equation of the tangent line at 4, 4. Tangent to this circle. So EDX of both sides. The derivative of this would be a chain rule. So it'd be bring down the 2 minus 1 times the derivative of the inside, which happens to be a 1. Right?
Yeah.
Plus this derivative will be the same, except it has a y component.
So it would be y minus 3 and 2 minus 1. Which is 1. Oh.
All right, so how do you deal with this? Now, let's go piece by piece, I guess. So it'll be 2.
Why
X
did
plus-
we write y minus 3 twice?
We have a chain rule.
Oh, I'm sorry. I
Right,
got
we
it.
did it here, and then we gotta do it again.
Yes, I got it.
The derivative of this is a 1, so that's easy. This derivative is just that.
Yeah.
This derivative is pretty much done.
2y minus 3.
This derivative will be 1 times dy dx, right?
Yes.
Okay, so the derivative is done. Any questions on the derivative step?
So for the d over dx x plus 2, we only put 1. But for the y, we put d1 times dy dx. Why is that?
So when you take a derivative that with respect to a different variable, see how this is x for an x?
Yes.
You do it just like you always have.
Okay.
But if you have an x with a y, you have to do it like this. Do it.
Okay.
You still do it the same way, but you add that extra piece.
Okay. Because this is different variable, right?
Yeah, a different. Yeah, it's a different rule for a different variable, right?
Okay. Got it.
Whenever the variables don't match, you have to do it.
Okay.
Okay. So now distribute, we'll have 2x plus 4 plus 2y
Minus 6.
dy dx minus 6 dy dx. Right? So isolate these guys, and then we'll be mostly done. Subtract those guys over. Factor.
Hey, can you move it up a little, Professor?
Oh, yeah.
Thank you.
Okay. Then divide, and we're almost done with the derivative stuff. At least isolating this piece. Okay, so this is your derivative. In order to answer the question, we need.
Can we not factor out the 2 from bottom and top?
We can. Yeah, the 2 reduces on both, right?
Yeah.
That's true. Pull it out, I guess.
Can you move it a little top because I can't see it? Thank you.
Okay, so you'll end up with negative x plus 2 over
X
y minus
y
3.
minus 3.
Back to the negative from the top, and I just put it in front for no reason. Okay. So we need use this formula. y minus y1 is equal to m tangent times x minus x1. So m tangent has to be found using the derivative, right? That's what we've been doing in the other sections over and over again. So plug in 4 into dy dx to find m10. This is also x1, y1. So m10 would equal negative 4 plus 2, 4 minus 3, which is negative 6/1. There's m10. You guys still with me?
How did you divide 4 plus 2 or 4 minus 3? Is there a specific formula? Because the formula is y minus y1 equals.
Oh, you're asking where this came from?
Yeah.
This.
So instead
Remember.
of x, we put 4, right?
Right, to find the m tangent, the slope, plug in
Okay.
this 4 into your derivative.
Okay.
That's what we did here.
So we put 4 and 4 instead of x and y, right?
Let me show this step for the
Thank
notes.
you.
Oh, those are basically the points that they're giving you, right? On the problem.
Yeah, they want the equation of the line tangent to that point on the circle. That's why we're choosing these. Okay,
Yes.
so we got the slope. Now, y minus y1 equals to m tangent times x minus x1, which is going to be y minus 4 equal to negative 6 times x minus 4. Just about out of space here. So y will equal negative 6x. 6 times 4 is 24 plus 1. Okay. Right out of space. So this will be your equation of the tangent line. Negative 6x plus 28.
So for negative 6 and x minus 4, how did we get that?
Huh?
How did we get negative 6 in x minus 4 on the right side?
The negative 6?
Yeah, the whole negative 6 x minus 4, everything on this one.
Okay, so this is the slope, right? So
Yes.
formula says put the slope here.
Mm-hmm.
X minus x1, which is the point, minus 4.
Okay.
Y minus y1, which is 4. So y minus 4 equals negative 6 times x minus 4. Solve
Okay.
for y and you'll get the equation of the line.
Okay.
This is the tangent line.
Got it. So that was what they were asking for, right?
Yes.
Okay.
Find the equation in the tangent line, which requires a derivative to find the slope and a implicit derivative to take care of the circle.
Okay.
So now the equation of the line that's right next to this point is that y equals negative 6 plus 28.
I'm not sure. I mean, we have to see that in Desmos or something.
I'm sorry?
Can we put the equation in Desmos to see if the graph is matched with the assignment one?
You want to plug it into the thing?
Yeah.
Sure. Let's see.
I know it's right, but I just want to see the graph.
Oh, you want to graph it?
Yeah.
Sure, yeah, let's do that. All right, so this was the equation of a circle. Oh, crap. My, I need a new computer, man. All right, so that's the original circle.
Yes.
The point that they care about was this one. The line that we solved for was the tangent line. Right here.
Okay.
It was tangent to this point.
Okay. Do we care about the slope of -6 or not?
I'm sorry?
Do we care about the slope -6 in the graph, or is it just to find the equation?
I mean, it's, I'm not sure what you mean, but we need the slope to find the line. And the slope represents a negative
Okay.
rate of change right at this point.
Yes. Got it. Thank you.
But yeah, you need the derivative to find the slope, and then once you have that, you can use the equation point slope form. Right, so in a nutshell, find the derivative to find m. Once you find m, plug in the m and the point to find your line. That's technically all you're doing. It's just that the derivative is super annoying. You see what I mean? Like the idea is basic, but the algebra and the steps can be long.
Yeah.
Any questions on 12?
No questions for me.
All right, I guess we can, let me see here. 9:30. All right, now we'll stop here. Try working it out, and maybe next time we can see if you have any questions, and if not, we're gonna go move on into, let me see, 9 point October. Yeah, let me show you. So 3.6 is super basic. It's just a formula. It's just basically using a formula. It's not very hard. Once you see it, you'll see what I mean. 3.7 is the word problems. So we'll probably do the word problems next. And then if there's time, we can rush through this because it's basic. That should be the plan for Thursday.
So I didn't do test 1 review. Does that affect my grade?
I think it might be, let me see.
Because I wanted to do it, but it's closed because I did the exam already.
The reviews are not part of your grade.
All right.
They will not affect it technically.
Oh.
Um,
And